Good. Now you're asking at the systems level, not just what is hash map, but how JS engines actually implement it, how GC is invoked, how OS versus runtime responsibility split, how arrays or primitives are stored. Let's go deep but structured, like how you describe Linux services. First, hash map, real JS engine view versus GUN grow. You already understand the book model, key to hash to index to array cell. That's teaching model. Real JavaScript V8 engine version. JS objects are not simple arrays of cells like the book. They are more like object equal inside this hidden class to structure info, and then properties is the hash table or the dictionary mode. Step by step, realistic mental model. You write cons object equal member name value Garrett, comma member age value 26. In memory, first heap allocation 0x100 to object. Second, internal structure simplified 0x100 shape to name, comma age, then storage to hash table. So inside of this object, the internal structure of this 0x100 is really shape, is to name and age, and storage is to hash table. Now third, hash table inside object. So we have index to key, comma value, then 0, or the 0 here is to name and Gareth, and 1 is to age and 26. But internally, we hash the string name to bucket to pointer to value. Important difference from book model, array of cells, real.js, dynamic hash table. Book model, key to index directly, real.js, key to hash to bucket. Book model, simple, real.js, optimized plus hidden class. So again, by default, with the real JavaScript, it uses a array and then just use the hash map for complex objects. Collision handling, real, instead of simple array of arrays, engine use open addressing or chain buckets. So internally, bucket S or bucket 5, we have member name, comma value Gareth, then member Nema, comma question collision. Our array is contiguous in JavaScript, not guaranteed like C. Fast case, yes, contiguous. Cons are equal array of 1, comma 2, comma 3. V8 uses packed array, contiguous memory. So, like by default, an array still is contiguous for simple array, but for like a complex array or like this, but if you do this cons are equal empty array and then we push a value to array 1000, we get a sparse array which now use the hash table mode just like with an object type. So again, arrays is the same as an object type, so it still use those dynamic storage structure depending on how the storage are being accessed or being used. So arrays can become type dense, storage contiguous, type sparse, storage hash map. Third, where are primitives stored? Short answer, usually stock or inline in object. Example, let x equal 10, stock x equal 10 inside object. Let obj equal member age value 26. For heap, we have an object Member age, value 26, stored inline, not pointer. But strings or big data, let obj is equal parameter name, value Gareth, then heap parameter obj to pointer to string stored separately. Fourth, garbage collector. This is what you really want. You ask, is GC like a Linux service who invokes it? Is GC is like a Linux service who invokes the GC? Is it an OS? This is key mental module. GC is not OS. GC is not a Linux service. GC is part of the JavaScript engine V8. Fifth, who controls GC? OS gives memory. V8 engine manages memory. GC is part of the V8. So life cycle, first your app runs. Let obj equals to member data, value 1, so allocated in heap. Then second, memory keeps growing. Third, GC deletes or decides to run, not OS, not you. V8 decides based on heap size threshold, allocation rate, idle time. So if your heap size threshold in your V8 or in your server exceeds, therefore the GC runs. If the allocation rate also exceed, it will also run. And idle time exists, it will also run. Think of GC like this, Linux analogy. You said like parent service spawning worker, good intuition. But here's the correct mapping. In Linux world, systemd manages services, and then service handles requests. In JS world, V8 runtime manages memory. GC is the background worker inside V8. So the runtime that is provided to V8 are the one being used to manage memory, while GC is the background worker inside V8. So GC is like a background thread inside the runtime, not a separate process. 7. How GC actually runs step by step. Step 1, stop the world. Sometimes JS pauses briefly. Step 2, root scanning, find roots, global variables, stock variables, closures. So this is the key. In JavaScript, there's this thing as a global variable where it is not really enclosed in a module or a class, and it's available in all of your application code. So it scanned that first, and then the stock variables. So all of those variables that is defined in your modules, and all of those closures. So the closure is the last because those has states. Third, mark phase, mark obj1, then mark obj1.child, then mark obj2. Step 4, sweep phase, delete everything not marked. Step 5, compact, optional, move memory to avoid fragmentation. Number 8, example, real flow, function test. Inside is let obj is equals to member data with a value 1. The next line, test function. During execution, in stock, we have test function obj2 0x100. Then for heap, 0x100 is the actual data, member, and a value 1. So after function ends, stock will become empty. Then heap 0x100 will be unreachable. So at first, during the execution, the test functions are in the stock, right? It is referencing the object 0x100, and the heap still have the data. But after that function executed or it ends, then those heap will be unreachable and the stock will be empty for the other function to get into the stock. Now GC runs new references. It will now delete 0x100. 9. When exactly does GC run? Not fixed like a cron job. So a cron job is the one that are doing batch or scheduling batch jobs in Linux or batch service. It's not also not OS scheduled. Trigger conditions. Heap is getting full. Many allocations happening. Idle time available. Types of GC in V8. Minor GC, young objects. major GC or garbage collector full heap. Final collection, everything together. When you do this, const obj equals to member name value Garrett. OS allocates memory space for process. Then V8 allocates heap object. So again, so as you can see, the OS just allocates memory for the process, but the V8 are the one responsible for allocating the heap, not the OS. So you might think that the OS allocate heap or stock, just like with the normal OS processes or desktop and laptop applications. So for browser, it is different. It allocates heap object, it creates hash structure, and then store properties. So this hash structure is the responsible for being able to retrieve the value of the hash, whether it's via object or whether it's via stock primitives, or sorry, whether it's via object like an object or an array. So it uses this dynamic or based on storage retrieval query. So if you retrieve like a simple array or object, it will use the stock. While if you use the complex one, discrete hash structures are the one responsible for being able or for providing you the ability to hash the complex object or array. Now stock, obj is the pointer to heap. Later, obj will be equals to null, then gc deletes unreachable, deletes memory. The real simplified truth, if you remember nothing else, hash map JS object. So an hash map is just a JS object, the one that we are using to get an O1 retrieval for our value. So we have key to hash to bucket to value. Now array is a contiguous fast or hash map sparse. So array could be non-contiguous as well, or a sparse array if it is complex and if it is being used as a hash map under hood. Now GC is part of V8, runs automatically, tracks reachability, deletes unused memory. So the GC is like part of like a thread of the V8, and it's kind of like running automatically, kind of like the services or the parent service of Linux. It tracks the reachability, so its main use is to track the reachability. So it does that with constraints, like if the heap is getting full, many allocations happening in idle time available. And then deletes unused memory. Now OS versus runtime. OS gives memory, V8 manages memory, GC cleans memory. So perfect. Now we're finally at the real call of JavaScript internals. How V8 actually turns key and value into something like hash map. So we'll explain this in layers so it clicks, not just in form. First, destroy the misconception. You learn object is equal hash map. That's only partially true. In V8, objects are not always hash maps. They have two modes. First, fast mode, hidden classes, default. So those hidden classes is the fast mode or the default settings that is being used under hood by our storage. Second, dictionary mode, hash map. This is the fallback. Second, fast mode. This is the real default. You write const user equals to member name with the value Garrett, then member age with the value 26. V8 does this internally. Step 1, create a hidden class. So hidden class C1, property name offset 0, property H offset 1. So this is contiguous. So that's what the engine does under hood. Step 2, store values like an array. So after it does this hidden class with a property and an offset, it create this array. So we have user with the member Garrett, comma 26. So the Garrett is an offset 0 and then 26 offset 1 coming from the hidden class properties. So this is not a hash map, it's like a struct or array layout. So when you do user.name, V8 does load offset 0, no hashing, no lookup, extremely fast. Why this works? Because V8 assumes objects usually have consistent shape, like const A equals to member name value A, member age value 20, then const B equal member name value B, member age value 30. So same structure, same hidden class. Fourth, when does it becomes a hash map? When the objects becomes messy. For example, const obj is equal empty object, then obj.name is equals to string Garrett, then obj.age equal 26, then delete obj.name, then obj.random equal true. So it is if it become messy and complex, then it becomes a hash map. Now V8 says structure is unstable. Now switch to this dictionary mode. Dictionary mode, real hash map. Now internally, obj to hash table. Now the hash table hash age to bucket to 26. Then hash random to bucket to true. This matches your JUN grow model, key to hash to bucket value. So the one in hash table actually match the JUN grow book of data structure and algorithm for hash map. The default value or like the dynamic change is that the one is that is not captured in the book. So the truth is JS object is equal fast array like structured, default, or hash map, which is the fallback. 6. How hashing actually happens in V8. Let's zoom into dictionary mode. Example, obj with the parameter string name. Step 1, convert key to internal form. So we have name string to hash code integer. Step 2, find bucket. Hash percentage table underscore size to index. Step 3, resolve collision. Now we have bucket to linked entries or probing. Step 4, return value string Garrett 7. Where is this stored in memory? So we have stock obj to pointer to 0x100. Now heap 0x100 dictionary. We have buckets to array, entries to key value pairs. 8. Why V8 doesn't always use hash maps? Because hash maps are slower than direct access, more memory overhead. Fast mode is predictable, cache friendly, JIT optimizable. 9. How this connects to React. So React state, we have const user comma set user equal use state with an initial value of object with the member name value A and member age value 20. If you mutate cleanly, like set user member name B age member age 25, it stays in fast mode because it is not messy. If you do messy mutations like user.random equal true, delete that user that name, media grade 2 dictionary mode. Then hidden classes. This is the magic, so this is the default mode. Think of it like class user, then inside name and then age. So think of that before being an array. It's like a normal class like this, class user with the property name and age, but created automatically. So these classes are created automatically under hood. Transition example, Let obj is equal empty object, then obj.name is equals to string a. Now z0 to c1 added name. So z0 or class 0 is now uh, spawned like a class 1 with an added name. Now obj.age equal to empty, then c1 to c2 added age. So if we do this, obj.age equals to 20, we added an age to this name. Now c1 becomes like a class 2 with an added age. Then v8 builds a tree of shapes from those classes. So even though like we're using messy computation, sorry, is it messy? No, it's actually not messy. So the reason is we create a hidden class because obj.name is equals to a, we're just adding name, and then obj.age equals to 20, we're just adding 20. So for non-messy, this is what the storage look like under hood. We're actually creating class automatically. Now v8 builds a tree of shapes from that and then access that via offset, and it's fast. 11. Final mental model. This is what you need. Forget simple explanations. Use this. JS object in V8. If stable structure, hidden class 2 array of offsets. So it's fast. If dynamic or unpredictable, we use hashmap dictionary mode. So again, in an object or object types in V8, if it's a stable structure, it uses the hidden class and create a class automatically plus an array offset, which is fast. If dynamic or unpredictable, it uses hashmap or dictionary mode. 12. Why your confusion happened? Because source, books, when grow, model, always hashmap. Source reality V8 is a hybrid system. So the deepest insight, JavaScript objects are optimized for predictability, not flexibility. That's why React prefers immutability, consistent object shape equal faster, random mutation equal slower. So if you have consistent object shape, which is kind of what we do with TypeScript, it's faster. And then random mutation is equals to slower. And then React prefers immutability. So that's the reason why React prefers immutability, because of those underhood storage of JavaScript. Now UI notifications. Next, let's imagine we have a web application responsible for displaying a real-time stock information. The application might have a grid displaying the stock stats and a counter indicating the last update point. The application must update the grid and counter when the data model change. In this scenario, our subject, which will be publishing topic/notification, is the data model, and our subscribers are the grid and counter. So the subject here, which will be the publishing topics or notification, is our data model. So as you can see, different like scenario could have different like the publishing or top could have different subject. So here it might be counterintuitive to have a data model as your subject, because usually data model is at the back end, right? And our subscribers are the grid and the counter. So the one that's subscribing in this publish model is the grid and counter. And again, they are not required to like know the observer and the observant I mean the one being observed, just like with observer pattern. So when our subscribers are notified that the model has changed, they can update themselves accordingly. So you can think of this as well, just like with the database. When the data model change, the UI front end could decide if they will update their UI or not. In this case, those are grid and counter. In our implementation, our subscriber will listen to the topic new data available to find out if new stock information is available. Now the topic here, the one in publish or topics, publishing topics or notification, is the new data available where or from where the grade and counter will subscribe to if they want to receive the notification. So if a notification is published to this topic, it will trigger grade update to add a new row to our grid containing this information. So let's say the grid subscribe to this. If a notification is published and new data available, it will trigger a grid update to add a new row to our grid containing this information, which is our subscriber. It will also update the last updated counter to log the last time that data was added. So it will also update the counter subscriber because it is also subscribed. So in this case, both are subscribed, but they can also choose not to subscribe. Now here, return the local time to get used in our UI later. So we create a get current time function. So we have const date equals a new date. So we created the new date function or object. Then const m equal get that month, and then return, and then we add a new row of data to our fictional grid component. So const add grid row is equals to data console.log update grid component with data. So this is how we add the grid row. See, this is the method we use to add a new row of data to our grid subscriber, and then update our fictional grid to show the time it was last updated. So update, this is the update counter, console.log last, and then get current time. So we use get current time inside of this update counter, which is the function we created initially. And with add grid row, we created we use the data yeah the data that the row has been added. Now update the grid using the data passed to our subscribers. So this is actually how we actually update it. So this, we just add a grid row, but when we want to like use the data that is being passed to our subscribers, then we don't just want to add grid row but to also pass that data. So this is the const grid update is equals to topic comma data. Inside is if data is not equal undefined, then add grid row, which is this the function we defined, and then update counter and also parameter data. So it uses the counter and data. So we initialize those functions, the counter and add grid row without data, and then this const grid update is now with data, and then create a subscription to the new data available topic. So const subscriber equal pub/sub that subscribe to parameter new data available comma grid update, which is this actually updating the grid and the counter with data. So this is how we subscribe to that new data available topic. And the following represents updates to our data layer. This could be powered by Ajax request that broadcasts that new data is available to the rest of the application. Publish changes to the grid update topic representing new entries. So pub/sub that publish parameter new data available comma, and then object with a member summary value Apple made 5 billion, then Next line member identifier value APPL, the next line stock price member value 570.91, then closing, then pubsub.publish. So we have parameter new data available again, and then with an comma, another parameter object with this summary, member summary value Microsoft Main 20 million, comma, member identifier MSFT, comma, next line member stock price with the value 30.85, then closing.